Let's take a look at the basic overview of fuel systems. Current generation fuel-injected cars basically have one of two types of fuel systems, a return system or a returnless system. Let's take a look at the components and see how each of them work. All systems start with a fuel pump. The fuel pump is going to be mounted in the tank in most applications, usually on a hanger or in some cases an assembly called a fuel pump module. So we can have the fuel pump separate or in a module assembly. From the tank, we leave the tank and go next to the fuel filter, usually mounted on the rail of the vehicle, meaning the chassis or frame rail will have the fuel filter housing on it, which obviously contains the fuel filter, which we need to service on a regular basis. Also, obviously important as part of the diagnosis in the system. From there, we'll go up high-pressure fuel injection lines, keeping in mind that most of our fuel systems today are under pressure, so we need to make sure we have the right rubber components on the car to ensure, obviously, safe travel. From the lines, we're going to go up to the fuel rail. The fuel rail itself is a fuel rail that's mounted on the engine that houses the fuel injectors. So the fuel injectors themselves are in a fuel rail. These are going to spray the fuel into the engine. Obviously, a 4-cylinder will have 4, 6 will have 6, and 8 will have 8 accordingly. From the fuel rail and the injectors, we're going to stop on a return system at a component called the fuel pressure regulator. The fuel pressure regulator is what maintains our pressure in the system. It controls the exact pressure of the fuel system to make sure we have good drivability. So we go next to the fuel pressure regulator. And finally, from the fuel pressure regulator, there will be another fuel injection hose that will return back to the tank. So on a return system, what makes it fundamentally a return system is the fact that we have a return line that comes from the fuel pressure regulator and ends up returning fuel back to the fuel tank. This is how a return system works, and obviously many current generation cars today use that. The later trend in fuel systems is something called returnless systems. And what makes returnless systems different is where the components are laid out, and most importantly, we remove one part. The part that we don't have on a returnless system is the return line. This is why they call it a returnless system. The return line itself that returns fuel back to the tank is not there. On a returnless system, we only send the fuel to the fuel rail that is needed to run the car. We don't return any back to the tank. So let's see how that would be laid out, fundamentally different than a return system. While we'll still have a fuel pump in the tank, or most commonly on a returnless system in a module assembly, what is different is in the tank itself, in the module assembly, will normally be the fuel pressure regulator. So what will happen is we will regulate the fuel pressure not at the fuel rail like we did on a return car, but in the tank itself. So the fuel pressure regulator is normally mounted in the tank in the fuel pump module assembly along with the fuel pump. From there, we will travel out again the high pressure fuel hoses, and on some cars we will go to a fuel filter itself. The reason that I say on some cars is on some vehicles we have no external fuel filter, but if we do, it's going to go from the pump to the high pressure line to the fuel filter assembly itself. From there, once again, we'll go to the fuel rail, which will house our injectors just like we had on a return system. So our injectors will supply fuel. The difference is any fuel that is sent to the rail is used by the engine. We don't return any back to the tank. So that's the basic difference between the two most common fuel systems on today's vehicles. Now that we've looked at the differences between the basic fuel systems, let's take a look at some additional specifics for fuel pumps themselves. Electric fuel pumps are normally found in the tanks in either a pump-only or module configuration, but there are some exceptions to that. For example, some 1986 to 1991 applications used a solenoid or inline frame-mounted pump. After 1991, most electric pumps became in-tank pumps. These in-tank pumps were submerged in the gas tank and attached to a mount or a metal hanger or sending unit. This style of pump existed till about 1997 when modules then took over. A module is an in-tank pump inserted in a plastic reservoir. This plastic reservoir stayed full of gas, ensuring the vehicle would stay running in a low fuel situation. Now, mechanical pumps still exist in older vehicles, especially for years prior to 1987. So we always have to be concerned, does the vehicle have a mechanical pump if it is an older application? And of course, diesel vehicles use a different fuel system altogether. As a quick overview, a diesel uses a low pressure pump or inline or feed pump to send diesel fuel to a higher pressure injection pump. The purpose of the high pressure injection pump is to build high pressure to send to the diesel fuel injectors so the diesel fuel injectors can spray fuel directly in the combustion chamber.